Lesson 3.5, Equations of Parallel and Perpendicular Lines. Essential question, how can you write an equation of a line that is parallel or perpendicular to a given line and passes through a given point? Can you use slope to partition directed line segments? Let's start with the directed line segments. We want to find the coordinate of P along the directed line segment A to B so that the ratio is in a 3:2 ratio. Okay, so what does it mean by that? Well, a 3:2, so 5 parts. 1, 2, 3, 4, 5. 1, 2, 3, 4, 5. So in a 3:2 ratio means we want to put P right about here and we want to find the coordinates of it. All right, so let's go ahead and first state that really what we're looking for is 3/5 of the way from A to B. Because there were 5 parts altogether, we want to go 3 of those 5 parts. So we're going to use slope to help us. And slope is rise, which happens to be 6, and run, which happens to be 3. All right, so what I want to do is I want to take my rise, and we're going to go 3/5 of my rise, which is going to be 18/5 or 3.6. I'm going to do the same thing with my run. I want to go 3/5 of 3, which is 9/5 or 1.8. So I want to go over run 1.8 and I want to rise 3.6. So where's that going to put me? Here I am at, to get to P, I'm going to start at the number 3 and start at y equal to 2, and this is what I want to do. I want to run 1.8, so starting at 3, I want to go over 1.8, and starting at 2, I want to rise 3.6. So that's going to put me at the point 4.8, comma 5.6. So this point right here is 4.8, comma 5.6. All right, let's go on to this next problem. All right, so let's go ahead and try again. I notice I have 4:1. I want to go in a 4:1 ratio, which means altogether there's going to be 5 parts. So I really want to go 4/5 of the way from A to B. 4/5 of the way. So I'm just going to eyeball it. It's right about here, 4/5. So 1, 2, 3, 4 out of the 5 ways. Okay, that's going to be P, and I'm going to try to find its location. And we do it using slope. Slope is equal to, and you can see my rise is 1 and my run is 7. So first I'm going to take a look at rise, and I'm going to go 4/5 times 1, which is 0.8. I'm going to look at my run, which is going to be 4/5 times 7, which is 28/5, and 28/5 is 5.6. So I want to go 5.6 over, and then I want to go up here, I want to go 0.8. So here's P. Remember, I'm starting here at the point 1, 3, 1, 3, and my run will be to add 5.6. You can see right here, I want to go over 5.6, and I want to go up 0.8. So my P will be 6.6, comma 3.8, and that is a coordinate. Those are the coordinates for point P. All right, stop the screencast right now and see if you can do number 2 on your own, keeping in mind the strategies I just gave you. Okay, and here is the answer. 3 to 7 means you want to go 3/10 of the way from A to B. You're going to take a look at your slope, which is the rise is 4, the run is -6, and you want 3/10 of your rise, 3/10 of your run, and those are the numbers you're going to add to point A's coordinates to get to that location. Okay, so let's take a look at these two theorems, slopes of parallel lines and slopes of perpendicular lines. Now, parallel lines, it says two non-vertical lines are parallel if and only if they have the same slope. If they happen to be both vertical, and let's talk about vertical. Vertical means the slope is undefined, and they're both undefined, which makes vertical slopes parallel. Slopes of perpendicular lines, if and only if the product of their slopes is -1. Some teachers teach that the slopes are opposite reciprocals. That may have been what you were taught in Algebra 1. Let's talk about a vertical slope. Remember, it's undefined. And in order for you to have perpendicular, the other line will have to have a slope of 0. So a slope of 0 and a slope that's undefined will make perpendicular lines. All right, let's take a look at these lines and decide which ones are parallel and which ones are perpendicular. And again, it depends on slope. So I'm going to find the slope of A, the slope of B, the slope of C, the slope of D. Okay, and the slope of A, I'm going to look for 2 points on A, and here's my rise, a rise of 1 over 2, over 3, 1/3. Now I'm going to look at B, I'm going to look for 2 points, rise of 1, run of 2, so 1/2. And now I'm going to look at C, rise of 1, run of 2, 1/2. And now I'm going to look for 2 points on D, and it looks like it's going to be -2 because you're going down and then over 1. So this will be -2. Now once I have that, I can make some decisions. These slopes are the same, so that tells me that these lines are parallel. Now these slopes right here are opposite reciprocals, or their product is -1, so we know that these two are perpendicular. Okay, here's a problem for you to do. Stop the screencast, see what you can do, and I'm going to give you the answers. Okay, here are the answers. I've identified all the slopes, and I noticed that the slopes that are the same make lines parallel, and the slopes that are opposite reciprocals, or their product is 1, are perpendicular. All right, let's take a look at writing an equation of a line passing through the point -1, 1 that is parallel to this line. So I've drawn the line. I want to remind you how to graph lines. This represents the y-intercept, which is right here, and this represents the slope, so I'm going to go up 2 units and then over 1, and then you can continue to go up 2 over 1 and then just draw your line. And of course I've graphed this point right here. So what I want to do is I want to write an equation of a line. Now you need 2 pieces of information. You need to know the slope and you need to know a point. Now the point they've given me, it's -1, 1. And since they're asking me about finding a line that's parallel to it, then I just take a look at this slope and I make sure it's the same too. So I have gotten the important information, and now I'm going to write the equation of the line using point-slope form. Now point-slope form looks like this. Y minus y sub 1 is equal to m times x minus x sub 1. Now I'm going to put in red y sub 1 and x sub 1. Y sub 1 and x sub 1 is this point right here. And of course m stands for this slope. So now I'm going to put all those values in. And I'm going to put 1 in here. My slope is 2. And this is x minus, and then this is my -1. That's x sub 1. And now I'm going to simplify, make it look a little nicer. And this is the answer. This is the equation in point-slope form. Now I'm going to go ahead and graph this. And so here I am at this point -1, 1, and I'm going to go through a slope of 2. So up 2 over 1, up 2 over 1, up 2 over 1, and then I'm going to use my line tool and go ahead and draw the line, and you can see it's parallel. Okay, let's now find an equation of a line that's perpendicular. All right, so I want to write an equation of a line, and I'm going to need to need to know two things. I need to know the slope, and I'm going to need to know a point. And the point I already have, 2, 3. Okay, so I've been given a hint that I'm working with 2x plus y is equal to 2. I'm going to move the 2x to the other side, and it'll become a little bit more familiar to you. I can see my b, which is right here, and I can see my slope, and I go down 2 units over 1, down 2 units over 1, and that's how I graphed this line. So this line is the same as this one right here. I just wrote it a little differently. Now, I want a perpendicular line, which means I don't want a slope of -2. I want a slope that's opposite reciprocal. So I want a slope of 1/2. And now that I know my slope, I can use point slope form to write my answer. Okay, remember I already have my slope and I have my point. So I'm going to use my point, and then here's my slope, 1/2 x minus 2. And this is the answer they're asking me to give. And I'm going to go ahead and graph it so you can see it. Here's the point right here, 2, 3. And I want to have a slope of 1, 2, up 1 over 2, up 1 over 2. Or I could go down 1 over 2. And then I'm going to use my line tool. And there we go. That line that I found is perpendicular to the given line. Okay, I'd like you to try. You don't have to graph. You can just find the answers, the equations that are being required there. Stop the screencast, try it, and then resume. Now here are the answers. Notice how I'm utilizing finding the slope, finding the point, and then put it in point slope form. In number 5, I want you to notice that x equal to 4 is a vertical line. I've graphed it right here to show you different points that have 4 as x. And this slope is undefined. Y equal to 2 is a horizontal line, and I graphed it for you with some various points. Notice that all the y's are 2, and this slope is 0. So whenever you have an undefined slope and a 0 slope, you have perpendicular lines. We want to find the distance from the point 1, 0 to this line, y equal to opposite of x plus 3. Okay, so in order to find a distance, I need to find the equation of the perpendicular line with 1, 0. So here's 1, 0. I want to draw the perpendicular line. Okay, which requires two things. It requires a slope and it requires a point. Now the point I've already been given is 1, 0. And since I'm looking for a perpendicular, I'm going to look at this slope right here, and I want the opposite reciprocal, so my slope that I want is 1. And now I'm going to write the answer. Y take away 0 is equal to 1 times x minus 1. I'm going to clean this up, and it's really, if I distribute, it's going to just be x minus 1. So this is the line I want, all right? And here I am right here at 1, 0, and you can see my slope has to be 1. So up 1 over 1, up 1 over 1, and then I'm going to use my line tool, and I'm going to draw my line. And you can see that they're going to intersect at the point 2, 1. So what I'm trying to say is that this line that they originally gave us and the line that I found when I actually solve them, 2y is equal to 2, y is equal to 1. You can see that using your algebra you're going to get y equal to 1, but visually I could see it was 1 as well. And if you end up putting y equal to 1 in here, your x is going to have to be 2. So now I have found where it crosses. It crosses here at 2, 1. But that's not the answer to the question. The question says to find the distance. And remember, distance is a perpendicular. And I know this is perpendicular. I know here's one of my points, here's my other point. So my distance will be requiring the distance formula, which is going to be 2 take away 1, quantity squared, plus 1 take away 0, quantity squared. And that's going to be 1 plus 1, which is root 2. and root 2 is approximately 1.4. So that's the distance, and that does look like a little bit more than 1. Okay, your turn. Go ahead and see what you can do. Stop the screencast, see if you can find the distance from this point to that line. Okay, here's the answer. Notice that I did graph them to help you. You want to find the slope of the given line, which is 1. The slope of the perpendicular line will be -1. I wrote my equation. I went ahead and simplified it a little bit because I wanted to show you the algebra that goes with it. But when I graphed it, I could see it went through the point 3,7. Now, to find the distance, you're going to have to find the distance from 3,7 to 6,4, and that's my work right over here. This is the end of the screencast.